Hey, welcome to Fractions Assignment 3. Can't believe I'm still making these videos, but you just keep watching them? Some of you are. Either way, today we're going to go over our Fractions Assignment 3. So if you need some help with a specific question, check in the timestamp below. Otherwise, come jam to my Nintendo Chill playlist and we'll do the worksheet together. All right, let's math it up. All right, that was corny, right? My point at the camera thing. I was like, yeah. All right. I'll try not to do that too much anymore. Just kidding, I'll do it all the time. All right, so I'll get out of your way here and we'll get started on our worksheet. So we're going over factors, multiples, and as we get down, we're gonna actually add and subtract some fractions, which is new to some of us, review for some of us, but we'll see. Let's get through this. All right. Question number 1A. 1A. It says list all the factors of each. So the number is 18, and we're looking for factors of 18. So that means any number that can multiply into 18 or divide 18 evenly. So I'll try and put them in order. They are, I'll put it underneath. 1, 2, 3, 6, 9, and 18. And of course, these wonderful factors make our little factor tree. 1 times 18, 2 times 9, 3 times 6. Am I forgetting any? I don't think so. Question 1B. All the factors for 20. Of course, we always start with 1. 1 always like the most common factor for anything. 1, 2, 4, 5, 10, and 20, right? So if you do the factor rainbow, we have 1 and 20, 2 and 10, 4 and 5. Usually numbers will have a partner, unless it's a square, like 25 will have 5, but it's not like there's no partner because it's a square, 5 times itself. Kind of digging this. It's like a darker Nintendo jam here. All right, 30, question 1C. 30, we're always starting with 1. It's an even number, so 2 is going to be a factor. We're going to have not 4, but 5. We're going to have 6. Yeah, 6. We'll have 10, 15, and 30. Now we can check this, right? This is my factor tree, factor rainbow. 1 and 30, 2 and 15, 5 and... there we go. So that doesn't mix. So we have... let's take these two. All right, let's back up a little bit. Let's just add it in here. 3, erase, comma, 3, comma, there it is. That's missed 3. So now 1, 30, 2, 15, 3, 10, 5, 6. Pairs, it's not, 30 is not a perfect square, so there should be a pair for everything. And the last one for question 1D is 28. So 1, 2, 4, 7, 14, and 28. Write that 8 nicer there. And 28. So 1 and 28, 2 and 14, 4 and 7. If I missed any, I don't think I did, but could happen. All right, so find the greatest common factor for the two. Oh my goodness. 5, 6, and 15. So the greatest common factor, the biggest number that goes into both of these numbers. So let's write 15 and 6, and we'll do the ladder technique. So, and number that goes into both of them, say 3, and that would be 5 times 3 and 5 times 2, and the next two here, nothing other than 1. Nothing other than 1 will go into those two numbers. So this will be our greatest common factor, 3. B. And 20 and 10. So 10, 20, doesn't really matter what order you write those in. We'll again use our factor ladder. I'm just going to draw this a little tighter. Our factor ladder method. So you probably know already what the answer is, but let's humor this a little bit. Let's say we thought it was 2, and that would be 5 and 4. No, sorry. Greatest common factor for both of these numbers. I want to get 10 and 20, and 10 is going to go into both. Whoa, what happened? Just like jumped to the bottom of the page. Sorry about that. The greatest common factor, I'm going to say 10. I can sort of see that here. Goes in there once, in there twice. So yeah, so this will be the greatest common factor. But look, I'm just going to back that up a little bit, just so if you didn't know, like if you, for some reason it was more difficult and you didn't actually know, and you went 2, and this would go into 5 times, and this would go into 20 10 times, and then you went to the next rung on the ladder, and you were like, well, there's still a common factor between these two numbers, and that's 5. And that goes in once and twice. And now with 1 and 2, there's no common factor other than 1. But now you have 2 rungs on this ladder here. So there's like 2 rungs here and here. You'd simply multiply 2 and 5 to get to the greatest common factor. 2 is a common factor, 5 is a common factor, but it's not the greatest common factor. So you'd multiply 2 and 5 to get to our 10. Right? 10 is the greatest common factor. Question 2, C, 14 and 21. We'll write 14, we'll write 21, we'll draw our ladder method, and we're looking for a common factor of both of these. Knowing our multiplication table is really helpful, so we'll just go 7, and that's going to be 2, and that's going to be 3. Now we're down to our primes. 2 and 3 are both prime numbers. There's no common factor between them. 7 is going to be our greatest common factor. 12 and 24. 12, 24, again, just practicing our ladder method here. Let's humor this again, and let's say we chose 3, and 12 divided by 3 is 4, and 24 divided by 3 is 8. And that brings us to a second rung on the ladder, and they still have a common factor of 4, which is 1 and 2. So now because we have two numbers here, and we're looking for the greatest common factor, we'd multiply these two, and that would give us 12. Greatest common factor. So what some of us might do also is just see that right away. They might say, well, 12 goes into 24, and 12 is a factor of itself, so 12, 1, 2, right? Sometimes you don't always see that immediacy, the immediate relationship, so you can go through the process. Ooh, 3 numbers. All right. When it comes to 3 numbers, 24, 16, and 40, now it's harder to see those relationships. The more you have your timetable sort of down, the easier it is to see these relationships, but let's see if we can get there. So 12's too big. 8 does, let's go 8. So 8 is a common factor. It goes into 24 3 times, 16 2 times, and 40 5 times. And all of these numbers don't have a common factor greater than 1. So 8 is going to be our greatest common factor. 40, 24, 48. This is going to be similar to the last one, I can tell already. Let's go through a different process. 40, 24, 48. Let's pretend I didn't see the relationship right off the bat. They're all even numbers. And so I can divide by 2. So that'd be 20 times, 12 times, 24 times. So now, again, they're all even numbers. What happens if I divide by 2 again? That's 10, that's 6, and that's 12. So now, last time, they're still all evens. I can still divide them in half by 2. Oh, my 2's ugly there. 5, 3, and 6. Now, do all of 3 numbers have a common factor? No, 3 and 6 do, but not all 3 numbers. Because this is a 5, just an ugly 5 here. So we're going to go 2 times 2 times 2. 2 times 2 is 4, times 2 more is 8. Our greatest common factor is going to be 8. Again, you might have saw that right away if you know your timetable. Otherwise, go through the process. All right. Lowest common multiple. We'll also use the ladder method for this. So a number that they both multiply into, 9 and 12. And if you know your multiplication table, you can kind of get there, but growing a strategy with easier numbers is the best way to practice. So let's go and line these up, and let's go through the ladder method. So I know that they have a common factor of 3, and that's going to be 3 and 4. And do they have a common factor? They do not. So what we're going to do is we're going to go around the corner multiplying 3 times 3 times 4. 3 times 3 is 9. Let's go 3 times 3 times 4. 3 times 3 is going to be 9 times 4. Right? 9 times 4 is going to be 36. I'm going to move that, I guess. So my greatest common factor is going to be 36. 36. 3B. Oh my gosh. 15 and 18. Some big numbers here. 18. 15. I'm just going to get rid of that. Okay. Let's do our ladder method. They are both divisible by 3. 18 divided by 3 is going to be 6. And 15 is going to be 5. And from this point, I cannot divide them further. All right, sorry, but just had to run out for a second. Okay, so we are using the ladder method here. 3 times 6 is 18, 3 times 5 is 15. So we are kind of here. We can't, there's no common factor for 6 and 3. So we're gonna have to go from here. So when we do our maths, we're gonna go, okay, 3 times 6 times 5. So 18 times 5, I know that 20 times 5 is 100. So 18 times 5 is going to be 90. So our lowest common multiple is going to be 90. 18 and 15. Now, 3B. It's always nice when you like check your answers. 3B right here. 90. If you can see it on my page. Okay, 21 and 28. What is going to be the lowest common multiple of these two numbers? (21), 28. Oh my gosh. 21 and 28. So I know that both of these are divisible by 7. 7 goes in there 3 times and 4 times. So 21, 7 times 3 times 4 will be the lowest common multiple. 7, let's show our work here. 7 times 3 times 4. 7 times 3 is going to be 21 times 4. 21 times 4 is going to be 84. 84. So our lowest common multiple will be 84. Check our answers. 3C. 3C right here. 84. 18 and 27. So 18, 27, 27. So I know both of these numbers are divisible by 9. Yes, 9. 9. 9 times 18. 9 times 2 is 18. 9 times 3 is 27. So we're going to go 18. 9 times 2 times 3. 9 times 2 is 18. Times 3 is going to be 30, 54. 54. The lowest common multiple will be 54. Ooh, 3 numbers now. This is fun. Lowest common multiple. Oh, this is a good one. Again, if you know your if you know your times table, it makes things so much simpler. It just makes life. Let's do this one. so much more efficient. Like, I know the answer is going to be 40 already. 20 times 2. Sorry, that's not right. I guess I better do my work then. My initial guess was totally wrong. Okay, so let's go. 20, 24, and 8. Let's do the ladder method here. So 20, 24, and 8. The lowest or the greatest factor I can think of is going to be 4. 4, that goes in 5 times. It goes in 6 times and goes in twice. Yep. All right. Then there's no common factor for these ones. I guess you could go. No. You could. So with this, you can go one step further and just drop the 5 down and then go 2, and then it's 3 and 1. It doesn't really change too much. And we're going to get 4 times 2 times 5 times 3 times 1. Really, the 1 is redundant, but let's do it anyway, right? So we just did this 4 times. We went around the corner and multiplied all these together. But let's show our work now, because it's fun to show our work. It's important. This is going to be 8. And draw a nicer 8. And then we'll drop down our 5. And this is going to be 40. And we'll drop down our 3. And this is going to be 120. And we'll drop down our 1 just because we should. 120. E. 120. And 3E. There it is. 3E 120. So not too bad. Let's look at the next one here. 3F. 3F, can you see it? There it is. 3F 18. 24. 20. Ladder method. Common factor. I don't know. What's common factor? 6 doesn't work. 4 doesn't work. Let's go 2. They're all even numbers. So that's going to be 9. That's going to be 12. And that's going to be 10. So let's go 3. That's going to be work for 2 of them. And 3, 4, and we don't do anything to 10 because it's not a factor. And I don't mind the 10 being there actually, because it's a nice, even, easily multipliable number. But just to play, we could once again go one more line and do 2 again, and that would be 3, 2, 5. All right, are we ready for this? It's gonna be fun. 2 times 3 times 2 times 3 times 2 times 5. Oh my gosh. All right. Show my work here. 6, drop down the 2, 12, drop down the 3, 36, drop down the 2, Oh my gosh. 72F, the biggest one at the end here, times 5. Now, there's a few strategies you could use here. You could actually just do your math, or you could double it and then half it. Like 72 times 10 is going to be 720. And then it'll be half of 720. Or you can just half it and add a 0. What's half of 72? Half of 70 will be 35, because we just did this, so 360. We just did that here, 36 times 2, 72, so 360. Rather than doing math, let's take a shortcut. 360. Let's make sure that's right. Well, I'll write it here because I'm confident. 360. 3F. 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 There it is. 360. Okay. Now we get to start to think about these. Okay, so we're adding fractions. Adding fractions, adding fractions. We can do this. We can add fractions, right? Find the sum. So first we want to do is we want to identify what we're working with here, and it's 1/6 over 1/6. So because these have the same denominator, all we need to do is combine the numerators on top, which makes this really easy. 2/6. Now, that simplifies to 1/3. But really, I'll accept either right now. 1/4 and 2/4. Same denominator. It's going to be 3/4. That's as simple as that gets. You can just add your denominator, your numerators on top. Okay, so step 2, adding these types of fractions. So we can work simply with one side here. So all you need to do is find the lowest common multiple of the lowest common multiple of the denominators. Lowest common multiple of the denominators. And the denominators in this example are 3 and 6. The lowest common multiple of 3 and 6 is actually 6. So we're going to rewrite this number. We could go through the steps of finding those. So you 3 and 6 and do the ladder method, and 3, 1, 6. Sorry, 3. No, 2. And then find the lowest common multiple. You multiply these three numbers together, right? 3 times 1 times 2, which is going to equal 6. Right? So if you remember, I'm in the way here. If you remember the steps we did for the questions above, like this is easy right now. You can actually just see there's a relationship. So you don't have to use those to get there, but you can. So 3 and 6 are going to actually be okay, so what you have to do, you have to turn 3 into 6 times 2. And if you do the bottom and the top, you're creating an equivalent fraction. And let's rewrite this fraction. So this will be equal to 4/6 plus 1/6. So what I've done is I've created an equivalent fraction, but this equivalent fraction has a common denominator, right? So this fraction and this fraction are the same, but now in this example, these two fractions, they have a common denominator. So we can just add the tops, and our answer is going to be 5/6. We get to play this game again. Lowest common multiple of these two numbers of this fraction. Lowest common multiple. Sorry, D. So what's the lowest common multiple of 2 and 5? 2, 5. There's actually no common factor of 2 and 5 other than 1. So we're just going to go, we're going to multiply 1, 2, and 5, or multiply the other. And this is something they call cross multiplication. So what you're going to do, let's take my red here. You're going to go 2 times these two numbers, and 5 times these two numbers. And what that might look like afterwards, after all this deleting, is simply times 5 times 5 times 2 times 2. So you're multiplying this whole side by this denominator, and this whole side by this denominator. And this is going to bring us to equivalent fractions. So this is going to be equal to 5/10 plus 2/10. And so we've created two equivalent fractions, but now they have the same denominator. So hooray, we've done it. Now we just simply need to add the tops. So this is going to be 7/10. And it does not simplify any further. Circle my answer. Next question, 5/12 plus 1/6. We're going to, again, find the lowest common multiple of 6 and 12. So we can go 12, 6, and what's the common factor of both is going to be 6. That's going to be 2 and 1. And we're going to be left with 6 times 2 times 1, which is going to be 12. So lowest common multiple of 6 and 12 is 12. We already knew that, but I'm just showing my work again. And how do I turn this 1/6 into something 12ths, right? So they have the same denominator. And we just did that here. We multiply it by 2. 6 and 12. So we're going to go times 2 times 2. To create an equivalent fraction, we need to multiply the top and the bottom by the same number, which is going to leave us with 5/12 plus 2/12, which will be our new fraction, or our sum of 7/12. That'll be our answer. Now this one, again, 4 and 5 are not going to have any common multiples. So right away, you need to realize, they're not going to have any common factors. So I can show my work and go, 4 and 5 and do my ladder method, 1, and it just leaves me with 4 times 5 underneath. So this is going to be, again, an opportunity to cross multiply. we're going to multiply the one fraction by the denominator of its partner. So we're going to go times 5 times 5 times 4 times 4, and it's going to leave us with equivalent fractions, but now we'll have an equal, the same denominators. So it'll be 5/20 times 8, no, not times, plus 8/20, which will be 13/20, and you cannot simplify that. 5a. Okay. Hey, look at that. They have this common denominator again. That makes things simple. So if we have a common denominator, right, our denominators here, common, we can simply multiply our subtract, find the difference of, that's what it says, find the difference between 11 and 6, which is going to be 5/12. This will equal 5/12. Right, all I need to do is subtract across the top here. B, hello again. A nice, simple, already have the same denominators. So we can simply jump right into subtraction of the numerators. So this is going to be 3/7. That will be the difference between 6/7 and 3/7. 3/7 difference, or 6/7 subtract 3/7 is 3/7. I'm just gonna circle my answer. Always remember, circle your answer. So 5/6 minus 1/2. Now, in this one, we realize 2 and 6 have some common factors. So we can cheat a little bit. We don't have to cross multiply. There's a common multiple that's lower than multiplying the two denominators. So we can find that common multiple with our ladder method, or you can just figure it out if you know it. That's great, but ladder method is always there. What's the common? 2 goes into both of these numbers, which 3 times once, so 2 times 3 times 1, which will equal 6. So how do I turn my 2 into 6? Because my other number already has a 6 as a denominator, so that's the lowest multiple, common multiple. I'm going to multiply by 3 on the top and the bottom on the numerator and the denominator. So I'm just going to change this song. It's way too like romantic here. All right, that's a little better. So let's write our equivalent fraction statement. The 5/6 will remain the same, but we're going to subtract 3/6 instead of 1/2. They're equivalent, and that will leave us with 2/6. And 2/6 can be simplified by dividing the top and the bottom by 2 to 1/3. So 2/6 or 1/3 is an acceptable answer. Totally fine with that. Okay, so we have 1/4 and 1/2. 1/2 minus 1/4. So again, they have definitely both even numbers. They have some common factors. I'm going to skip the ladder method. These are so easy to work with. And we're just going to go, how do I turn 2 into a 4 because that's the lowest common multiple of these two numbers. Multiply by 2 on top and the bottom. Write our equivalent fraction is going to be 3/4 minus 1/4, which is going to equal 2/4 or 1/2. Right now, I'm in the way again. Right now, I am fine with leaving a fraction like this in unsimplified terms because that's where we're at in our learning. In the future, this will not be correct because it's not simplified, but right now, we're good. 2/4, that's good. 1/2, that's great. Last two questions. Once again, the ladder method is not going to help us here because there's no common factors greater than 1. 4 and 5. So this is going back to that cross multiplication. So we're going to times each other, one fraction by the denominator of the other fraction. So this fraction is going to be multiplied by the denominator of its partner fraction. And same with this one. So we're multiplying 4 by 5 and 4 by 2, 5 and 4 and 5 and 5. We'll write out our equivalent fraction. Song's like almost a... All right, I'll leave this song. I like it. So our equivalent fraction is going to be 25/20 subtract 8/20. So this is going to be equal to 17/20. 25 minus 8 is going to equal 17. That's it. That's our answer. You can't simplify that. They don't have a common factor other than 1. Last one. Now 6 and 7, did they have a common factor? They do not. So once again, we're going to be cross multiplying 6 times those two and 7 times those two. We can write it like this, times 7 times that's not a 7, that's times 7 times 6 times 6. So this is going to be equivalent to 49 42 over 42, subtract 30 over 42. So 49 and 42, this is going to be equal to 19/42. And 19 is prime. So that is going to be our answer. Cannot simplify. 17/20 and yeah, all right. That's it. We're done. Thank you for tuning in again and watching and participating. I hope this helped you. Remember, if you want to help us out by giving us a like, you don't even need to like this channel. Come find us at GB Gaming. We're the Panthers. We're the Electronic Athletes. Come check us out on our Twitter. No, on our Instagram. And we are Gordon Bell Gaming. Connect with us. Otherwise, I hope you have a fantastic evening and you keep that math